If you looked at that video, anybody look at the video or no? I don't know what you guys were doing, maybe eating too much cake, but you'll see that the review for this test is difficult because it's all word problems. So it was difficult for me to really do a review because it's just one giant concept, and that is what we've been doing for the last 2 months with moles and everything else, yes? So what I decided to do was to do that review, that it's only 5 minutes, and then do a bunch of little videos, like 3, 4, 5, 6, 7, 8 minutes long at the most. 8 minutes would be almost too long, on different types of stoichiometry. Clear? And last period I did six quick movies. This period I'll do another 6, and this is what I did. Okay, I did mole, mass, mole, mass, mole. These are all the ones you're going to have to know. Clear? You have to know all these, yes? I did, you know what, let's write them somewhere up here so we can click them off as we do them. So, mole, mass, mole, mass, mole. I did volume, and I also did I don't remember. Mole volume. Okay, we're going to have to do volume mole. We're going to have to also do mass volume and volume mass. All those different types are going to be on the test. Just one, not, one or two of each. I mean, it's not going to be, you're not going to be driven out of your mind completely, just partially. So those are the various types. Now, I've done most of them already. So I'll just keep doing these until the end of the period. Clear? Yes? And then don't forget, your homework's due today, and your test is the next time we meet on Wednesday. Clear? Are you all right with that? Okay. All right. So let's do. I think we got down somewhere here. So let's do these. Let's start with these. I think I did 2, 3, 4, 5, 6. I think I may have done those. I did 6, but I think I did most of those. So let's start with these two, okay? Now this is the test. And what I'm doing is I'm doing the chemical reactions right from the test. So there's also problems on percent yield, where you need to know actual yield and theoretical yield. We'll do some problems there. Also, limiting reagent, we'll put those up there too. So we've got a lot of work to do today. All right, let's do one let's do a problem that is, let's see. All right. Let's do the old standby equation. And that is the the hydrogen plus nitrogen yields ammonia, okay? Yes? And the mole ratio is going to be 3, 1, 2. Clear? Yes? Okay. Let's say that this is going to be 100 grams. Clear? I want to know what volume this is. What volume of ammonia is 100 grams going to give me? Now, you are obviously assuming that there is enough nitrogen, plenty of nitrogen. So it's going to be 100 grams of hydrogen reacted, and what volume of nitrogen? How would you do that? Anybody? How would you do it? Give me an idea. Yes?
First of all, let's try to do a mole-mole ratio, or a mole to mass.
Mole to mass. Okay, I'm not sure where you're going with that, but keep going.
And then after you do that ratio,
Okay.
try to do or actually scratch that,
Okay.
do a mole to volume ratio.
Okay, mole to volume ratio. So you want to do mole to volume. So are you suggesting that you're going to turn that mass into the number of moles? Is that what you're suggesting? Yeah, and that's what I would do. Very good. So 100 grams of hydrogen would be how many moles? 100 grams of hydrogen would be how many moles? I hope you don't need a calculator, but you could. I mean, not a problem really, but What's the mass of 1 mole of hydrogen gas? 1? That's what I've taught you. Hydrogen gas is H2, and you're telling me 1 mole of hydrogen gas is the same mass as 1 mole of elemental hydrogen? Or did you make a mistake and you're willing to recover and tell me that 1 mole of hydrogen gas would be 2?
Yeah.
Correct. Excellent. Well done. Okay. So 100 grams would be how many moles?
200.
If each mole is 2 grams, how many 2 grams are there in 100 grams? You can do this, Abdullah. You can do it. You can do it. How many 2s go into 100? 50. So how many moles would that be? 50. Good. So I can convert this to 50 moles, right? Yes? Easy? Okay. If I have 50 moles of hydrogen, how many moles of ammonia is that? How many moles of ammonia is that? Did you do it?
Said he fixed it.
Great, thank you, sir. Excellent. Yes, you did. Wonderful. How many moles, right, so what volume is 50, I'm sorry, how many moles of ammonia will 50 moles of hydrogen give you? What? You mean? Yes. Hi.
You don't say when I look from the window.
Sorry, I'm filming.
Do I?
But it's okay. What do you,
I was looking for Victoria, but she's
Victoria is not in this class. She's in my section 3. Go on. So, what would that be? What's 2 times 50 divided by 3?
Approximately 33-ish total.
33.3. So how many, what volume would that be? 33.3 moles.
Oh,
time, we'll do it.
That's 746.6.
740, can we say 748? What did you say it was?
746.6.
So 747. Okay, so it'd be 747 liters. Yes?
Sorry, it's
Finished?
No.
No?
745.92. It's not that.
All right. Did you use 33 or 33.3?
33.3.
All right, let's do it again. All right. Why did we come up, this is a pretty simple problem. Why did we come up with such varying values?
Because he used 33.3.
Oh, I see. Okay, just 33.3. That's okay. All right, so 7, what? One's place, man.
45.92.
746.
Yeah.
Is that right?
Yeah, pretty much.
Okay, good. So what did I do? You're given 100 grams of hydrogen. You want to come up with the volume, right? Well, how many convert to moles? Yes, easy. Okay. 50 moles. Do a mole-mole conversion. 50 moles of hydrogen converts to 33.3 moles of ammonia by this ratio. Yes? Yes or no? 33.3 moles. 22.4 liters per mole. I get 746 liters. Easy? And that was what? Mass. That was mass volume. Clear? End of mass volume. Easy?